to do in this video, if you are new here or if you haven't seen this video right here, Did Liars and Thieves Misdiagnose This Car? We are discussing a phenomenon in this video that we have seen on this channel, and I have seen personally outside of filming videos for this channel. We have seen a phenomenon where occasionally you have a car that has a blown head gasket. And when I say blown head gasket, I should clarify because some people commented on this. When I say a blown head gasket, I mean that the combustion gases under compression are escaping into the cooling system. This can be through a bad head gasket. This can be through a compromise in the block, a cracked cylinder head. It could be through a warp in the cylinder head. There's all kinds of things that can cause that to happen. So when I say blown head gasket, I'm kind of generically mentioning that. But the point is, we have a absolute, irrefutable, provable compromise in the cylinder where those combustion gases are escaping into the cooling system, and yet a compression test doesn't catch it. The compression test shows normal compression, the same as a cylinder that does not have a compromise in it. And we wanted to do a couple things in this video. The first one is, how does that happen? And the second thing is, what do you do that we can still maintain our advanced diagnostics and be able to detect a compromise in the combustion chamber without having to do a leak down test on every cylinder? Because the leak down test ultimately finds the problem. But you don't want to do a leak down test on every single cylinder in an 8-cylinder car where maybe half the cylinders are under the intake manifold, and do all that only to find, oh, well, it's not a combustion chamber issue. It's clearly some issue where the intake manifold has a coolant leak maybe. You don't want to spend hours and hours and hours doing that diagnosis with all the manual work. You want to be able to diagnose it in a matter of minutes like we typically do. But in this last video and a couple of other times, that rapid diagnostic has failed. The tried and true compression test lied. And again, I should rephrase on that. There was a person who correctly commented, the compression test isn't lying. It's just misleading. It is accurately reporting the compression in that cylinder. It is not lying, but it is also misleading in that you think that you have a normal cylinder when actually that cylinder has a major compromise to it. So what we're going to do is go through your comments, go through a little bit of the video. I'll go through a little bit of my understanding on this. I also have seen where the compression test failed and the leak down succeeded, but I have another explanation of why that happens other than what it was in this video. And many of you guys know when I do a leak down test, I do it differently than the textbook method of doing it. And we'll review that and explain why that is. So after this video, it should change your diagnostic mindset and processing, as well as your protocols for determining if an engine has a major issue with a compromise in the combustion chamber. And that will be the purpose of this video, so it should be very educational. Your guys' comments were for me. There are some smart sons of bitches on this channel, and that is exactly the environment I was hoping for. The thing I am most proud of on this channel is not a single comment that said, hey, you should use quick block seal or whatever that stuff is. That is not going to ever happen on this channel. You're going to get people with real fixes, real explanations, real diagnostic processes, so that you don't just do stupid stuff. What we're going to do is, to catch up, if you don't want to watch the other video, although you should, if you don't want to catch up, what I'm going to do is show you the exact example of this particular problem, and then we'll get into the explanation of what exactly happened for those of you guys that don't want the suspense, and then we will go into some other things. So let's review exactly the issue that I'm talking about. So what we have here is a cylinder that has a combustion compromise to the cooling system. We're doing a compression test right now. That compression test shows 140. Now, I don't know what spec is on this vehicle. I don't care, because what we want to do, obviously, is we want to compare that with a known good cylinder, and that's what we're doing here. Okay, this will be a known good cylinder. This does not have a blown head gasket or compromise. We do our compression test here. It reads exactly 140. Exactly the same as a cylinder that absolutely is bad. What we have in the background here is also important. Well, that's kind of weird right there, isn't it? That's creeping me out. All right. Okay, for those of you who are familiar with this, this is a relative compression test. Basically, we have a video on this. Most of you guys are familiar with this, either through me or through maybe Scanner Danner or something. And what this does is it uses current from the starter motor to determine the relative compression between cylinders, because your amperage is going to dramatically increase as there is resistance in the starter motor as it's reaching compression top dead center in a cylinder while the engine is cranking. So as we can see here, there's a little anomaly here, and this is normal in these tests. The trick is, on this 8-cylinder car, 1, 2, 3, 4, 5, 6, 7, 8, we see it's not repeated. In another view, we see that we've got even compression in all cylinders. And one of these cylinders, again, with this particular test, the way we did it, we don't know the cylinder numbering. The bad cylinder is number 7. But there would be a lack of a peak or a strongly reduced peak in the amperage in a cylinder that has a compression compromise. As you can see, all cylinders read exactly the same. This was misdiagnosed by 2 professional automotive shops, and I believe if they did this relative compression test, yeah, they would have said, well, it's not a serious engine problem. Let's look at another way of doing this. I do want to show this. This is what you would find if you have a loss of compression in a cylinder. In order to do this, I just wanted to test and make sure my methods were working, that on the relative compression test, if there was a cylinder that had missing compression, that we could detect it. So by removing a spark plug from a cylinder and doing the test, you see your peaks, and then we have this cylinder here that has no compression because there's no spark plug right there. And then we see it repeats again. 1, 2, 3, 4, 5, 6, 7, 8. Also repeated back. 1, 2, 3, 4, 5, 6, 7, 8. So this reproducibility here shows that our method would have detected if there is low compression. The thing is, there is not low compression in the cylinder. There is not low compression in the cylinder, even though there is a compromise, and we'll get to the explanation on that. While we're at it, I wanted to show one more thing. I wanted to bring up very, very sharp viewer, and I'll show you his comment. On this here looks very similar to that amperage pattern that we did before, except this is with voltage. So with the amperage pattern, we're looking at the amperage from the battery to the starter motor. And here what we're doing is we're looking at battery voltage. The same thing happens. The battery voltage will actually increase, of course, as the amperage decreases. Ohm's law, and we talk about that over on my paid content channel so you can understand it. But anybody who understands basic electrical knows that this looks backwards. This is the same exact thing that we did earlier right here with the amperage, and we see that the voltage has dropped dramatically when you have the open cylinder, when you've got no compression. What I failed to say in the video was that I actually inverted the signal because I wanted it to overlay with the amperage signal that everybody is familiar with so that you could see the same overlay. Let me show you this viewer. All right, there he is. Jose Rodriguez, just awesome, absolutely impressive. You would think the voltage would go up on the low compression cylinder, and he's absolutely correct. It does go up. This image is upside down, actually. I just inverted this image so that you would match up a drop in the cylinder with a drop in the cylinder as you're used to with the amperage. But absolutely, Ohm's law, If your amperage decreased, your voltage increased, and that is exactly what happens. So another person pointed that out too. So it's always, I'm always so excited to see when people really get that and they really understand it. That was a fantastic catch. I actually mentioned I inverted the signal while filming, but I lost it in the edits. One of the things we want to do is, it sounds, if you haven't seen that video, like you're just trusting me that this cylinder with the normal compression on the relative compression test and on the gauge compression test, that you're just trusting me it has a compromise. Let me show you the evidence of the compromise. All right, our first evidence of a bad head gasket, I guess I need a better term for bad head gasket. Our first evidence of a compromise in the combustion chamber in one or both of the cylinder heads, we did using a chemical block test. And this is a blue fluid that if carbon dioxide gets into the fluid, it will turn the fluid yellow. The only way carbon dioxide would get into a cooling system is from exhaust gases. So while the engine's running, you just basically draw those exhaust gases, strike that. You draw the air from the radiator into this device, and if there is excess carbon dioxide from combustion gases in that air in the radiator, it will start turning that fluid yellow. What this test does not do is tell you where the problem is, of course. It just tells you there is a problem and it is combustion gases getting in there. So let's play this. Showing you that the fluid is blue. Right now the engine is running, and you just draw the air from that radiator right into the block tester. And you can already see right now it's turning yellow, like at 2 pumps. That's yellow right there. 3 pumps, 4 pumps. If it happens in like 4 pumps like that, yeah, there's no question. That's a problem. Okay, so we know we've got an issue there. How do we know where it is? The way that we know 100% for certain cylinder number 7 has a compromise in it is with this device here. This is a leak down gauge. If you're not familiar, what you do is you bring that cylinder up to top dead center compression stroke, and when that cylinder is at top dead center compression stroke, you go through the spark plug hole with a threaded sealed hose, and you basically put compressed air into that cylinder. There should be almost no compressed air escaping that cylinder through the valves, past the rings, or of course through any crack or failed gasket or gaps or anything like that. And it should build up a lot of pressure. And what this does is it measures how much air is escaping. You can also hear where the air is escaping, or in this case, we're going to see where the air is escaping. We're going to go ahead and play this. So what we're going to do is take off the radiator neck. If the air from my gauge there is going into the cooling system, of course it's going to bubble out the coolant. And it will do it in fairly dramatic fashion. So here we're going to turn on the air. All right, so here we're turning on the air. We're putting air into the cylinder. We can see a little steam come up in a second here. There it is. And the coolant bubbles up. Again, the engine is not running here. All we're doing is just putting compressed air into the cylinder. And that compressed air is escaping that cylinder and somehow going into the cooling system. Again, we don't know if it's bad head gasket or what. The car did have an overheat previously, most likely warped the cylinder head, blew the head gasket, most likely. It doesn't matter. Whatever the case is, it's a major, major repair. Now, the problem is that as you can see, the evidence that this cylinder number 7 had a compromise, conclusive. Absolutely it does. The compression test failed to detect it. The leak down test did. Why is that? We're going to go ahead and give you what I believe is the answer, and then we'll talk about some other things. All right. Many of you guys have brought this up as the explanation for what happened here. And of course, now my drawing skills are going to be a major limitation with your understanding this. But it's actually pretty simple. We've got our cylinder here. All right, and then we've got our piston here. All right, and our connecting rod. It's a very thin connecting rod. And then, of course, you've got your rings here to seal. And we have, of course, we have our head up here, and there's other cylinders. And we have coolant leaking so that when we're pulling down, when we're on the intake stroke, you've got two things. You've got suction from that intake stroke. You also remember the cooling system's under pressure. And with that cooling system under pressure, we're forcing coolant in here. So we get some coolant into that cylinder, of course. Okay, and actually what I'm going to do, make this easier, we're going to make the coolant green, like a traditional green coolant. So we've got a little bit of coolant in there. Now, as that moves up and we're on the compression stroke, well, the problem is that we're compressing this coolant. And what's happening in this particular situation that we occasionally find is whatever the leak is here, whatever it is, if it's a crack, if it's a head gasket issue, whatever it is, the coolant is not able to leave out of that gap with nearly the efficiency that it came in. And basically what's happening then is you've got normal compression because you've got the non-compressible liquid in that cylinder that isn't getting pushed out, as it is a lot of times when you have these issues. In this particular issue, it's just not getting pushed out. Now, why that is, not entirely sure that it's able to come in but not leave. But whatever the case, it is by far and away the most likely explanation, and it would be super, super easy to prove. And man, if I had that car back, I wish I had that car back and we would do some things. One of the easiest things we could do, you could just drain the coolant from the car and conclusively prove that this is the result of coolant in the combustion chamber, and that is it, period of end of story. You take away that coolant from the engine and you do your compression test and you find now the compression test works and shows low compression. It is undeniably because of the coolant. I want to redraw this and I want to show you another example that I personally have seen that will also cause this phenomenon. Incidentally, on the previous picture there, you can easily see now why the leak down test worked. The reason the leak down test worked, you've got your spark plug hole here. That you're forcing compressed air in here, but the piston can't be pushed down because it's perfectly at top dead center on that compression stroke, so it's pushing against the crankshaft perpendicularly, so it's unable to move. And that buildup of air pressure over time, and that's where the trick is, that's the difference. That buildup of the air pressure over time is going to start forcing that air and probably some coolant through that compromise, whereas the coolant was unable to do it because you're doing it while cranking. So the piston is just moving too fast, never giving it a chance to escape out of that path that it came in. But the leak down test is able to do that because you're using air. And second of all, because you can do the leak down test. I've had cars where I would do the leak down test up to 1.5 minutes before I would finally see the evidence of the leak show. So you've got time on your side with the leak down test, and that's why the leak down test works. Let me show you another variation where you can have a compromise in the cylinder. The leak down test will work if you do it the way I do. If you don't do the leak down test the way I do, you're going to miss it. But I'll show you the way I do the leak down test. and it's to catch if you have this situation happen. All right, your other situation that can happen is you've got your cylinder here. Now remember, your cylinders are in a jacket where there's coolant jackets surrounding the cylinder, all right? If you have a crack, let's say here in the middle of the cylinder, this can be a bit of a problem, particularly if it's really low down, particularly if your crack is near the bottom of it. So now you've got your piston at the bottom dead center, all right? And now your piston is on the way up to the compression stroke. So now your piston's moving up, just completely bypasses this small, remember we're talking a crack here, that's the size of my thumb there. We're talking a crack in the cylinder. And your piston is just completely bypassing that. Of course, up here you have no compromise here. You may have carried a little bit of coolant with it here, but you've got normal compression. The other thing you're going to have too is a normal leak down as well. You bring this up to perfect top dead center on that compression stroke. We go through our spark plug hole with our leak down hose. We insert 90 psi of air. Well, guess what? That air never escapes anywhere because we don't have a compromise up here. The compromise is down here. You missed it, right? So in this case, your leak down test and your compression test will fail. I have absolutely had that happen. That's why this is how I do a compression test. I did it in this video, and of course it showed that the leak was there, but then I also did it again at top dead center because I wanted to see, is this likely a head gasket issue? Of course, we saw it at top dead center compression. I just didn't show the original leak down test I did because I thought it detracted from the video a little. But let me show you how I do a leak down test to fix this. All right, so the way I do my leak down test is I have my piston down on the compression stroke, not top dead center compression stroke, bottom on the compression stroke. So my valves are closed, and what I do is I insert my compressed air into here, and it takes a minute, well, not a minute, but it takes a few seconds for that air to fill this cylinder with the piston at the bottom now, as opposed to filling up the little tiny combustion area when the piston is top dead center. But we fill up and we build that pressure up and we build that pressure up, and you see that leak down gauge pressure slowly increasing. And of course, it wants to push that piston down, and it will because you're not perpendicular on the crankshaft. But you are holding it in place manually with your breaker bar so that that piston can't be pushed down. And you hold that piston. After a while, if you have a compromise anywhere in this area, as opposed to only in the top of the combustion chamber, what's going to happen is that air starts finding its way out of that leak. In this case, it is to the cooling system, and you'll see the cooling system bubble over. What we should do is talk about the improved methods that people were pointing out in the comments, and many people pointed this out. Let's talk about an improved method that the next time I have this happen, we will do. To really test these methods, I also need another compression test that lies or misleads. And over the years, I'm sure eventually I'll get one. Maybe I can get this car back and talk to the customer about compensating him if I can do a video on it or something. I'm certainly not going to give him a cylinder head. But one of the methods for doing this would be, I had mentioned at the end of the video, I thought maybe I could use my pressure transducer, and then I quickly dismissed it as a useless idea because the problem is my pressure transducer being in the cylinder, it's useless because I still have to put it in every single cylinder in the car, and we're trying to defeat that. So the trick is using that pressure transducer, but not in the engine cylinders, but on the radiator neck. And basically, this is super oversimplified, but basically what this indicates is that we have some kind of connection between the cooling system and the combustion chamber, blown head gasket, cracked cylinder head, whatever it is. And of course, as that piston comes up, if we had that phenomenon that we had in the last video, where what's happening is we've got enough coolant in here that as that piston is coming up very rapidly, it's compressing that liquid. We get a high compression reading. Well, it is still pushing a little bit of that liquid ultimately to the radiator, where my only issue with this is that I'm not sure if having an air gap in the radiator neck, because the air would be easily compressible, if that would be a factor. There's some variables with this maybe, but the point is that we would build up the pressure in this radiator with every time that piston is trying to push that liquid back. And if we have the pressure transducer on the radiator neck, we would see those pulses of pressure pretty consistently, and as a matter of fact, simultaneously correlate those pulses with, on our scope, we would see those pulses and we can correlate them with an ignition spike on a known cylinder by connecting up to the coil or using an inductive clamp or something like that. All right, so on our computer screen with our oscilloscope, it would be more sort of like this, with these pulses showing up rhythmically, and every time we have a pulse, we have that ignition signal. We can now correlate wherever those pulses are. As a matter of fact, we don't even technically have to have the ignition pulse on that faulty cylinder because we would still have that same rhythm of pulses. And then if our signal pulse goes here, by using math to determine where that is in the crankshaft cycle, we would be able to determine still that there was another cylinder event here and one here, and then going through the firing order, we would still be able to determine the number of the cylinder that correlates to those pressure pulses we see in the radiator. And that is absolutely, I agree. Multiple people pointed that out. That is absolutely, I agree, I think the way that I would do it now is I would still do my relative compression test the same way. And if I still don't believe it, and I think it might be misleading, and there's still evidence that this may be a head gasket problem, then maybe set up and do it this way. And I totally agree, there is still a method that can be used in order to be able to determine a cylinder that has a compromise without having to do a whole ton of labor. So I think this would be the way to do it. Now, the only thing is that we would have to test this under exactly the circumstances where we have that misleading compression test, just to make sure. But in theory, this absolutely works. The other thing that I personally would do, because this is all assuming the foundational theory that this is related to the non-compressible liquid causing this phenomenon in the first place, I think the next time that I get a car that does this, I'm just going to drain the coolant from the block and show that now my compression test works. I think that's what I'm going to do. Yeah, what if the car doesn't have a radiator cap and it only goes to the reservoir tank? Yeah, there may be some variables with this. We'll deal with that when we get there, but in principle, this is the idea. All right, let's close out. Let's look at a few more comments that I thought were really, really good, very observant. I did want to point out a feel-good comment. Bill Nelson here, he's owned a shop for 15 years. One of the comments and one of the kind of life lessons I also gave in the video was that you do not have to rip people off in order to really be successful. As a matter of fact, it's the opposite. You'll be more successful through building a reputation of honesty and things. The irony here, by the way, the two shops that misdiagnosed this, I don't believe really they were thieves and they were lying and they were trying to milk this customer. I believe that they really didn't think there was a major engine issue. Well, the second shop, it's kind of hard to say because they kind of thought there was an unknown issue. I thought it was a little underhanded that they were trying to oversell the customer on all these extraneous repairs other than the engine problem. Maybe maliciousness at the worst. But at best, I think it was just good intentions that they probably did compression test and found that the compression was normal and they ruled out it was a serious problem. Still, you would think it's got to be an intake manifold leaking coolant. Except, as somebody pointed out, on this car, the intake manifold is dry. So it wouldn't be the intake manifold leaking coolant in this particular car, but that would be a variable if you proved it wasn't a combustion chamber thing. Here we've got our first guy, Eddie. Eddie Grant. I wonder if he lives on Electric Avenue. And he was the one that said, put the pulse sensor or my transducer onto the coolant neck. Absolutely correct, Eddie. And dozens of people, you see, everybody agrees with him too. Eddie nailed it. That's exactly right. And that's what we covered. Another one, MPH, and I kind of agree with this. He's been on the channel, God, since I first started, man. And what he's saying is that with the compression test, again, if you don't have a significant leak in that cylinder, even cranking, you're going as much as 250, maybe 300 revolutions per minute. And that rapid increase in pressure is it's just not enough time for that leak to occur. And I agree, it may have nothing to do with the coolant in the system. That's why I want to drain the coolant out of the system and see if it would have made a difference. But I agree, if you've got, if you don't have a significant leak, just think of if you have a syringe. Let me get one. So I've got this syringe here. This is the same thing as a cylinder. And I can tell you with the syringe open like this, I can just take my finger right here and I can just easily push that up. There is no resistance. There is no compression there. But I'm going to take this really thin diameter hose right here. This is going to limit pretty severely that ability for that air to escape. When I push it now, it's harder to push. For sure. Not even a comparison. It was way harder to push when you limit the air. Imagine that through a micro crack. So maybe it actually has nothing to do with the coolant. Either way, that compression would still be getting into the cooling system, and that picoscope measurement from the radiator neck, totally agree. Everybody's right. Another really good point. While we conclusively proved that this compromise was to the cooling system, Advanced Level Diagnostics, he's got a channel, by the way, too. And a way that the relative compression or the regular compression test can lie is with valve issues. And by putting the pressure transducer on the intake manifold, and I know that, I don't know that I have done a video on this, but I think I did on my paid channel. I think I did on my paid content channel, where I show that putting the transducer on the intake manifold, you can detect valve issues that way. So a really good idea there. Okay, just want to draw out Chris again, pointing out, like I was saying, maybe it's nothing with the coolant, but again, that air pressure building up because it can't escape through that fast movement of the piston. So Chris is right. But what I wanted to do is show Dave, being the scientist you are, why not explain the possibility of cracked cylinder head? Yeah, I've mentioned in other videos, when I say a head gasket failure, I refer to that in general. Cracked cylinder head, cracked block. It could be that you have a warp between the cylinder head and the block, and the head gasket actually isn't destroyed through that. So anything where you have a compromise of the combustion chamber, but he's exactly right. Tracy, Colorado. Yeah, he's in Colorado too. That is exactly right. One of the other things that I could have done is I could have pressurized the cooling system. I have a bore scope. I could have put a bore scope through the spark plug hole, and we would have been able to see the coolant leaking in. As a matter of fact, on my paid channel, I have a video where I do exactly that, and you can see the coolant where it's leaking in using a camera in the cylinder. So absolutely. Inside of my own mind, he's always on the channel giving good comments. Some of them a little caustic, but I'm the same way. Again, the physics of that leak escaping a small area, for sure. Let's see. Here is one that I agree this may be a way, doing that relative compression with the radiator cap removed. That is worth doing. That is absolutely worth doing. I think there's enough of an air gap that there's easily compressibility. I don't think it's compression that the cooling system is holding that compression. I think it's just the leak is so small it can't escape out of the cylinder in the first place. But still, well worth pointing out. It makes sense to have an open system so that the compression can escape. Let's see what else we got. This one caught my attention. I'd never seen this guy before in my life. I know your rant on investing was meant to convey a different message, but maybe you should go fishing a bit more often if dealing with those things or us is making you so angry all the time. There's 2 replies. I only replied once. Let's say I responded, that makes no sense to me. If you know the rant was meant to convey a specific message, why would you intentionally insinuate the wrong message? That's what I'm thinking. You are right about one thing. Most people would rather go fishing than change a situation they are dissatisfied with. That I agree with. And he responds, I was hoping you were smart enough to understand what I meant, but I guess I should have known better. Sorry for trying to help. Let's see here. No, you just aren't smart enough to be in this community. Let's go ahead and reply that. When you click on the guy's name, you can get to their channel, go to the About tab, click this flag, and you can block a user. Okay, good. There's Chris with the compression test lied. It told you the compression. Somebody else brought that too. Absolutely. The compression test didn't lie. It didn't lie. It absolutely accurately reported the compression. There is not a loss of compression in the cylinder. I think misled maybe would be the right word. It didn't lie. What I was trying to do, I have no idea why anyone would live in California. I tend to agree with that. I'll let you go ahead and read this one. At $1,800 to replace a radiator and a water pump and everything without determining there was engine failure first. I agree. It can be argued that shop, I think they owe at least for the labor. How are the puppies doing? We adopted them all out, by the way. What I was hoping to do was find one where somebody had pointed out that the temperature could be an explanation, that maybe when I was doing the compression test when the engine was cold, we were getting normal compression. But then as you warm up the engine, you might find that now you have the compression loss. It's a really good idea, but one of the things I want to point out is I thought the same thing. I did do the compression tests both with the engine cold and with the engine warmed up, and it showed exactly the same compression both times. Okay, quite honestly, there's so many other comments, and I know in the time I've made this video, I've probably got another 50 or so. Very, very good on the comments section in this video. And anyway, what I wanted to do is on this video, if you have any new ideas or different ideas on some things that you think may be helpful, let's put them here. The next time that I get a car with a bad head gasket, first of all, the first thing I need is a better nomenclature for the combustion chamber compromise. Because remember, it doesn't have to be a bad head gasket, and also it doesn't have to be a compromise to the cooling system. We're talking about any compression loss at all. So whatever, maybe that's just it. A car with compression loss. Although this car didn't have compression loss, did it? I don't know. I need a better name for it. Anyway, point I'm saying is the next time I get a car that has a issue with the combustion chamber composition, and there is a compromise to it, I'd like to try some other methods that you guys may also have. Also, ultimately, I highly doubt if we get a car that comes in and it has a compromise to the cooling system, we have seen the odds that it will also have a normal compression tester, very minimal. But if it does, we will definitely assess what is causing that problem conclusively and how we can do a scientific diagnosis on it without having to do a whole, convoluted thing like doing a leak down on every cylinder or some, crazy contraption or something. So that's what will be coming up. So I look forward to your ideas and responses. We will talk to you next time. Thanks for watching.